Hey everybody, this is Mr. Corb. We're going to go ahead and get started with Chapter 2, or Unit 2, Section 1, which is the Cartesian coordinate plane. This is where we do all of our graphing, and especially in later units when we start talking about linear equations, when we start graphing lines, points, everything, it's going to get a little crazy. So we need to make sure that we understand this section first. So we're going to talk about the Cartesian coordinate plane. So the Cartesian coordinate plane is two-dimensional. We have up, down, we have left and right. And we denote this with the x and y axis. The x-axis is going to be the horizontal. Is going to be the horizontal axis, the horizontal bar that's across the bottom here. So we can just go ahead and label this as we're going. So this would be the x-axis. Okay, and if you can think about this, and this is one of those concepts that I just don't know why. It's a challenge to try and remember, but to try and help you, think of horizon. If you can associate that with the x-axis, horizon is if you look across and you look out. If I'm looking out my window right now, and I can see the horizon. It's where the sky meets the ground, and that is a horizontal line. So that's where we get the word horizon. So that's our left and right movement, so we're going to be moving left and right, and that's going to affect the first part of an ordered pair, or the first part of a point, and we'll get to that when we get there. But the other part of a Cartesian coordinate plane is the y-axis, or the vertical axis. And the axis is this vertical one going up and down. This is going to be the y-axis. Something else that I wanted to point out with this x and y axis is if you look, our x-axis is, as we go to the right, our numbers are increasing. So if I were to actually write numbers down here, I could write this as 1, 2, 3, and so on and so forth. And those are the values for those x coordinates. Likewise, if you look at the y-axis and you go up, this is saying 1, 2, 3 on the y-axis. And that's going to actually change the second point in any ordered pair because it goes x, comma, y in a point. Okay, and a point is specific to a location in space, which our space here is the coordinate plane. All right, so let's go ahead. Let's talk about the coordinate plane a little bit more. Let's see this Cartesian coordinate plane. We start off, and if you can remember this as counterclockwise movement, and if you ever get to pre-calc, you'll actually understand why we call this, why we call them quadrants 1, 2, 3, and 4. It has to deal with the unit circle and how we start traveling around this unit circle in a counterclockwise measure. But you don't need to know that in Algebra 1, so that's okay. Just know that this is going to be quadrant 1, and we're representing this in Roman numerals, so I is 1. We're going to do I, captain. Nope, sorry, bad joke. Okay, so double I is going to be 2, and then we just keep working our way around counterclockwise. So just know that it goes 1, 2, 3, 4, going counterclockwise around, and then it's going to be IV for 1 less than 5. So V is 5 in Roman numerals. You're getting an extra lesson here. We're going to subtract 1 from 5 and we get 4. So it goes quadrants 1, 2, 3, 4. So we are going around counterclockwise motion. All right. And this point here in the middle is a very, very important point. It's called the origin. That's where we're starting. Everything, especially when you get into, if you ever get into physics, and you start talking about vectors, vectors always start at 0, 0. And then we can move in a positive vector motion at that point. Okay, so our 4 quadrants again are 1, 2, 3, and 4. And as I was talking about this earlier, one thing I left out was that we can go in the negative direction as well on our x and y axis. As we start venturing down here on our y axis of -1, -2, -3, and so on, we can also do the same thing with our x axis of -1, -2, -3, and so on and so forth. So just note that as we move to the right, everything to the right is going to be positive on the x direction. Everything above the x-axis in the y direction is going to be positive, and anything below is going to be negative. So we can start finding out what these 4 quadrants have as ordered pairs. Remember, it goes x, comma, y, and I'm going to write this off to the side. X, comma, y. So this is how far up or down we went and how far left and right we went. And we'll be using this the rest of algebra, so make sure that you understand that. So x is our first coordinate. So if we look at quadrant 2, which is up here in this top left, so this is quadrant 2, and remember we can represent that as a Roman numeral. In quadrant 2, what value is positive and what value is negative? Now if I pick any point here, so let's just pick a random point. This is going to be -4, so I'm going to write that -4, comma 2. -4, 2. Which one's negative? The x value is going to be negative, and that's going to be true for every single point in that quadrant. So we have negative with a positive y value in the second quadrant. If we go down here to our third quadrant, so if we come down to the third quadrant, we are going to have negative, negative, and you can see that on this axis. So we are going to have a negative, negative point. So we could actually just look at the points and know its location on the graph, and that's very useful. And then our quadrant 4, and I guess I can put a 1 up here. Our quadrant 4 is going to be our positive x values because we're on the right side of this y-axis, and we have negative y values. Okay, so that's the coordinate plane in a nutshell. Let's go ahead and just talk about these examples real quick here at the bottom before we move on to the next section. So if we have these 4 quadrants, let's solely look at if these are in these quadrants or not. So for this first ordered pair, both of these are positive. So if we have positive, positive, now I know that it's right above here, we can figure this out. So this one would be in quadrant 1. In quadrant 1. This next one, we have -3, 4. So it's a negative, positive, positive coordinate point. So negative, positive, we see is in the second quadrant. Number 3, we have 7, -2, so we have plus, minus. So plus and minus are positive and then negative. We have IV, which again is the Roman numeral for 4, so this is in the fourth quadrant, the bottom right. And then we have, I'm going to skip over this one for right now, but we have a negative, negative here at the end, and negative, negative we know matches up with quadrant 3. 1, 2, 3, boom, there you have it. So that's pretty easy. But what about this point right here? -6, 0. We have a negative, and then we have a 0. Now 0, it's been argued for many, many years if it's 0 is positive or negative, but 0 has no value. 0 is 0. It's a nothing, right? So we can't really put it in one quadrant versus another. So if we look up here and we find this point on the coordinate plane, so we have a x value of -6. So if we would come over here to -6, 1, 2, 3, 4, 5, 6, and 0, it's actually on this axis, right? So it's right here. It's on the axis. It's not in a quadrant. So it's teetering between this quadrant 2 and quadrant 3. So we can't do anything about it. We don't know anything about it. So what we state is that it falls on the x-axis, and that's all we say. So x-axis. Because we can't just list that it's in both quadrants, because really it's not, it's neither. It's in neither of those quadrants. So it is on the x-axis alone. Okay, so hopefully this has been helpful. These are the first section of our notes in Chapter 2, and this just gives you a general overview of the coordinate plane. All right, this is Mr. Korb, and I will see you later.